Our next speaker is Dirk Helbing, who's a professor of sociology at ETH Zurich. He has his PhD in physics and is also affiliated with the computer science department there and really, truly interdisciplinary in the theme of this conference. I'm sure many of you have seen his fairly innovative work on the dynamics and interaction of both pedestrians and vehicles. He's really developed the ideas of social forces and self-organization. He's doing some really exciting work these days with Living Earth Simulator, and very curious to see what he's got for us today in terms of the Nervousnet. So take it away, Dirk.
All right, good morning. The problems of the world are complex. We are faced with climate change, with financial crisis, with conflict and war. And so our world is actually exposed to existential threats. It seems that our conventional recipes don't work any longer, and that also our understanding of our complex world lags behind. So why is this? Well, if you look more closely into the problems that haven't been solved, then it turns out that the big unsolved problems of the world result mainly from systemic instabilities, I believe. This ranges from crowd disasters to traffic jams, for example. And the interesting thing about traffic jams is that they cannot be predicted even when knowing the thoughts of people. Why can I say this? Because there's a mathematical theory that tells us when traffic jams happen and why. Namely, when the density goes beyond a certain critical threshold, and then small variations in the speed will amplify. The next driver will respond with a delay. In order to compensate for this delay, he will trip the brake a little bit stronger, and next one even stronger, and then finally cars get stopped, although no driver really wants this to happen. So systemic instability means that even if you have data, even if you have good technology and the best intentions, your system may get out of control. And this is happening also for many supply chains, in particular for the world economic system, where we have booms and recessions. Crime is another example where we have an unstable social dynamics, or the tragedy of the commons, situations where basically cooperation would be good for everyone. However, it turns out that cooperation is an unstable systemic state, as the free traffic flow is unstable. So it breaks down, it erodes, and we have a tragedy of the commons in the end. Conflicts are also the result of social instabilities. In particular, it turns out that sanctioning mechanisms don't work well in multicultural contexts. And also, finally, revolutions can be understood as the outcome of unstable systems. In order to understand these kind of problems better, a few years ago we came up with the Future ICT project, and actually we gathered people around the world to work on this project together, because many of the problems we're faced with are global problems, and they can only be solved in a global effort. And in particular, it's very important to make an interdisciplinary approach. And this is why computational social science is so important, because it brings together social scientists with computer scientists and natural scientists. So this is really great, most needed. In fact, even though Future ICT wasn't funded in the end, it had quite some impact on what's going on in the world. And there are projects in a number of different countries, including the US, China, Japan, and also Russia. The latest country coming up with a related project is South Korea. And they're interested in working on opening up governance and having a participatory systems in which citizens are involved. Now, all of this has been driven by the availability of data. We are living in an age of big data. In just 60 seconds, we are generating 700,000 queries at Google, posting 500,000 Facebook posts, producing all sorts of location data, shopping data, and so on. And so the question is, could we build something like an X-ray for society to see what's wrong and heal it? So this idea is driving many people. And in fact, we can do that with some success. For example, we can measure the spreading of international tension. We can predict wars to some extent. That allows earlier intervention. We can predict epidemic spreading. And we can also predict nicer things such as global knowledge production, spreading of ideas, or even culture. The question is, what else could we do? And people have been asking, can we soon know everything? Or can we create a crystal ball that would see what's going on in the world at any place, at any time, or even predict the future? This was actually not the plan of Future ICT, but people are discussing these kind of things, and that's why I need to address it over here. Could one even run a country like a wise king or a benevolent dictator? And if one wanted to do this, then it was necessary, certainly, to manipulate people's choices. And that might be done with personalized information. So in fact, the question is, will we be remotely controlled? Or is this already happening? In fact, of course, we have personalized ads, and these personalized ads are intended at making our behavior change, make us buy certain kinds of products. And then the idea might be of some people that if your behavior cannot be changed the way the government wants it to change, then you could still use predictive policing. So the question is, I mean, that sounds a little bit scary, I guess, and that's why we need to talk about it. The question is, could such a society be built, and would we want to have such a society? And what are the alternatives? In fact, we're talking here about a cybernetic society, and this idea is pretty old. To run a society as a control system based on information, and that has been done by communist Chile many decades back. And it looked promising, but it ended badly, in particular for the president. And of course, we don't want similar experiment to end badly for our presidents and chancellors and so on. So we need to talk about, if we want to do it, and if you want to do it, then how to do it. So all of this is driven by the digital revolution. We have an exponential acceleration of processing power and of data and of artificial intelligence. And people are now talking about the possibility of superintelligence, are getting quite worried about it, as you have probably read on the news. We have companies called, for example, Recorded Future or Palantir, that are really trying to predict individual people's behaviors. And in fact, in many cases, they are pretty good at that. Can predict behaviors with more than 90% accuracy. And it seems that this would allow to predict the future of society, but we've done an experiment that actually shows this is not the case. Anyway, so there are experiments going on. For example, in Singapore, which considers itself as a social laboratory, and as we know, Singapore has had really large growth rates, and many countries are now asking, should we run our countries the same way? Or like China. And China has recently started a Chinese brain project. In fact, Baidu, the Google of China, has asked the military to join in a huge project. And the question is, what would it do? Well, for example, what it might do is to rate every single citizen for the behavior they're showing, including the behavior on the web. And the score you get would determine whether we can get certain jobs or not. So this is on the way, and people are talking about China as a model for other countries. In fact, some of this is already coming to our countries. For example, nudging, the attempt to use the technology used for personal advertisement in order to change your behavior. And that could even be used during elections, for example. Or pre-cops, which is predictive policing, it's there in Switzerland. However, powerful tools imply serious threats. And we need to be concerned because cybercrime is exponentially exploding. It costs us 3 trillion each year right now. It will be more in future. And in fact, every major company has been hacked. And also the Pentagon, the military, and everyone else. This is concerning, so we shouldn't have a lot of data in a central place. And also, mistakes will happen. Even the smartest superintelligence will make mistakes. In many cases, we'll learn afterwards whether a decision was good or bad. So we need to recognize that society cannot be steered like a bus, or even if you could do it, society wouldn't be functional anymore. We need to recognize that society is a complex system, like our body. And we know that more medicine doesn't help more. It would be poisonous to our body. So we need more wisdom rather than more power. And we need to learn how to be minimally invasive in order to get where we want. We also need to recognize that actually data volumes are exploding more quickly than processing power, and complexity as we go on networking the world is exploding even faster. So that means even though we have all this supercomputer power and all these data, we will lose top-down control, and we need to have a different approach, which is distributed control. So I personally believe that we need to focus on creating collective intelligence, which is a distributed intelligence that can handle the combinatorial complexity of the world. It can be adjusted to the problem. One of the biggest problems really when it comes to trying to optimize the world is the choice of the goal function, and no science is informing you which goal function to choose. Is it GDP per capita? Is it sustainability? Is it peace? Is it happiness? And that's why we need pluralism. If everyone does the same, then this could end in disaster. The other thing is that all of these data-driven approaches are nice, but they cannot predict what's happening after a systemic shift. It can tell you what kind of states have happened in the past. It can allow you to extrapolate, but a completely different state of society couldn't be predicted by this. But explanatory models could help you to some extent. So in fact, the best approach is combine some data with explanatory models. In fact, Google Blue Trend has been celebrated as a huge success of big data analytics, but recently criticized because it's not really as good as expected. Instead, you can do the following, that you combine data about infections of people, as the World Health Organization is collecting it, with data about the air travel volumes, and that allows you to define an effective distance that allows you to understand the spreading process, as we've published in Science over here. But we can understand many more things. We can understand pedestrian flows and crowd disasters. We can understand traffic congestion. We can understand booms and recessions. I can understand also blackouts of power grids, what makes gas supplies resilient. And we can also understand opinion information, social influence, coordination problems, cooperation, or the spreading of crime. Moreover, we can understand the evolution of moral behavior, which is kind of interesting, it makes humans special. And the evolution of social preferences. So why are we social in the first place? and the emergence of social norms and conflict. So there are a lot of papers. If you want to know details, then I'd advise you to read them. But then, I thought I would do that for the rest of my life. But then 2 years ago, I suddenly reduced my effort to model this world. And the question is why? Because I came to the conclusion that our world is to change dramatically, and partly because of the digital revolution that's going on, that's going to reshape all of our economic and societal institutions. And so we need to talk about design principles of our future world. This is what we need to work on. And in fact, I believe we can learn to understand the forces behind social and economic change. And as we start to understand these forces, we can learn that these forces work for us in the very same way as understanding physics has helped us to engineer systems. Now, the main success principle will be self-organization and the principle of the invisible hand. So what I personally believe is that we can create a world that works like magic. If we just come up with the right kind of interactions between system components in a complex system, then we can create almost any structure, almost any property, or almost any functionality. And the challenge for complexity science is to identify the right kind of interactions. And this can now be done. We can create feedback loops that would have the system behave in certain ways as we like it. But the idea is to control society not in a top-down way, but to have a bottom-up self-organization, to apply the subsidiarity principle enabled by an incentive system and a multi-layered approach. So the Internet of Things will make this possible. We will be able to measure the externalities, that means the external effects of our behaviors. And if we use this information and feed it back by means of a multi-dimensional incentive system, an exchange system, then basically we can let self-organization happen. So what do we need for this? I recommend a smart data approach, very similar to what CERN is doing. CERN is kind of the symbol for the way we should do science. So we make targeted measurements, and in fact, even though this is the largest civic big data infrastructure, they are throwing away 99.9% of all the data they measure. Why is this? Because they're just interested in confirming or falsifying a certain kind of hypothesis. And for this, they need certain kind of data. And all the other data is just noise for them. They're throwing it away. And depending on the experiment they're doing, they would keep other kinds of data. And rather than digging in a notion of big data, we should make, as scientists, this targeted measurement approach. And for this, we would need to create actually the measurement devices. And in fact, this is now possible. So our smartphone actually is today's universal tool. I don't actually use it to make phone calls. And the most interesting thing is hidden inside, which is the kind of 15 sensors to measure almost anything. And there will be even more sensors in the future. What can we use this for? Well, we can connect those smartphones in order to build a global measurement system. But if you want to do this, we want people to use it and participate, and it's important that we build a system that we can trust. And that's why I advise to build this as a citizen web. If one company or one government would collect all the data that will be becoming available through the Internet of Things in the future, we couldn't do a step or say a word without being recorded. So I really think this should be created and managed by the citizens themselves. And it's very important that you are in control, that you can control what kind of data are being recorded and whether you're just using it for yourself or whether you're sharing it with others. And even after the data have been shared, it would be nice to have control of the data that have been produced. And for this, a personal data store could be used. It has been developed at MIT by Sandy Pentland's team. So what can we do with these sensor data? For example, we can measure acceleration. Here is the XYZ measurement of acceleration, and if just one smartphone is shaking, that could mean that you're mountain biking. But if all our smartphones are shaking at the same time, that would be an earthquake, and then it's time to warn your friends and family and colleagues to get out into a safe place quickly. So that sounds like a good idea, I believe, doing collective measurements all together. So why don't we do this and create a participatory real-time data infrastructure together? Of course, we could wait until somebody is giving us these data, but Google and Facebook haven't given their data to us until today. We might wait forever for this. So now let's create the data that we need and we want to have and that are important for the future of our society. Let's create this data ourselves. What are we waiting for? So it would work like Linux or Wikipedia or OpenStreetMap. We build the system together as an open participatory system. So the success principle is give and take. That means you can take the data that you need for your experiments, for consultancy, to create new products or come up with a new service. But for this system to work, you should also share some data back. And the same thing, actually, with the source codes. And that means that the measurement protocols that have been developed by others can be changed by you, because we might have 100 ideas what to do with this system, but you have another 100 ideas, and you have another 100 ideas. So if we put all these ideas together in one system, then we're going to create a very powerful information and innovation ecosystem together in a very short time. And that would actually foster exponential innovation. And that kind of exponential innovation will be needed to create all the jobs that will be lost in the next years in the classical sectors. About 50% of jobs will be gone, say experts. So the approach is to create new opportunities for everyone. And if set up well, then enabling users, customers, and citizens will lead to better services, better products, better businesses, better neighborhoods, smarter cities and smarter societies. And with a micropayment system, actually everyone could establish an own business. Well, this is not a dream anymore. This is already happening, and my Nervousnet team, young, dedicated people, have been working on this to make it happen. And in fact, the planetary nervous system can do a lot of things for us. It can do real-time measurement, and this will allow us to create greater awareness of chances and risks of decisions that we might take. We might use the data in order to advance science, and also we can enable self-organizing systems and collective intelligence. So, for example, we could map noise in a city or in an entire country using the planetary nervous system. Or we could map luminosity. In fact, I will show you an experiment by the end of this talk. And we could create more awareness about the situation. We can create compasses for decision makers to measure not only GDP per capita, but also the state of the environment, health, social capital, such as reputation, trust, solidarity, or happiness. And we can also map crises or map resources and who uses them, or even the entire world in 3D using all the photos that people are anyway uploading about any place of interest in the world. So here are a lot of people who have taken photographs, and these were the points where the cameras have been pointing. If you put this together, then you can construct the Colosseum in 3D, and that you can do with any place in the world. So we can create a 3D copy in the digital world. So What I'm claiming here is that with the Internet of Things, the golden age of complexity science has started, because now we can come up with solutions and not just with descriptions. And here's one solution. It shows you that we can overcome this annoying stop-and-go traffic that we still have today. And so we'll soon see the reason for this annoying stop-and-go traffic as we elevate ourselves out of this car. And we're going to see that there is an on-ramp where some cars try to slip into the freeway, and that produces minor disruptions in the flow, and these are amplified. And as they're amplified, it creates this annoying stop-and-go traffic. Now assume that cars would be equipped with radar sensors. We did that, by the way, 10 years ago, long before people were talking about Google self-driving cars. Now, and these radar sensors would measure distance and relative velocities and drive your car automatically. Now, then this can increase not only comfort of driving, but also produce collective effects in the sense that it's increasing the stability of traffic flow and increasing the capacity based on local interactions, not central control. And it works even with 20% equipped cars, which is even more interesting. The same thing can be done for cities. When talking about traffic light control, we came up with a self-organized approach where the traffic flows are controlling the traffic lights rather than the other way around, based on local interactions again. And there are dramatic improvements, actually, for public transportation, improvements also for motorized traffic, and it's good for pedestrian cyclists too, and the environment. So we should really have this new approach enabled by real-time sensing, real-time data, and real-time feedback. And of course, for production, this is also extremely useful. The keyword here is Industry 4.0. So the question is, can we also build assistance systems for cooperation? And I personally believe yes. In fact, Elinor Ostrom has shown by empirical research that self-governments can be efficient given proper design principles. And it's our task to find these design principles. Reputation systems would be such mechanisms supporting social cooperation. Or a merit-based matching, which is not only good for people who cooperate, but increases the cooperation level altogether. Or competition, and in fact, compared to punishment, signaling is better and more efficient in many cases. Now, of course, in a diverse world, we need to create interoperability, and this will be done by digital assistants that each of us will use, and there are a number of them one can think of that will be fed by local data. And so, we're going to enter a new age of our society based on self-organization and real-time data and real-time feedback. And computational social science is going to deliver the solutions that we need in future. So get ready and join the Nervousnet community today, because this is going to produce massively increased efficiency. We'll have self-organizing, self-improving systems. It's based on a democratic principle of participation, individual autonomy of decision-making, and free entrepreneurial activity. But at the same time, it considers externalities, and that's why we will have fairer systems and better environmental solutions, and also more cooperation and less conflict. So let's do this together. And now, world premiere will show a small experiment. I hope it works. So please shut down your computers for a moment, and we'll soon shut down the light. I'll introduce Evangelos Pornaras to you, who is a developer of the Nervousnet. And we distribute a number of smartphones to people. Please, we need 6 people. Come forward. Actually, it would be good if you would stand over here. So thank you very much.
Okay, 2 teams, green and red.
Okay, so there are two teams, green and red. They're going to compete to catch light that I'm going to spend, with this flashlight over here, just to demonstrate that this is really working in principle. We need more phones. Oops. Hopefully I didn't do anything wrong. Team red, team green. So, who is team green? Okay, team green. So let me just check it. So please hold the end towards the audience. So are we seeing, okay, team green, so there is a measurement impulse. And should be working too. And in fact, it's working, and now let's check out team red. And also this is working. So fantastic. So we're ready for the competition. Please get a bit closer and mix. I mean, we should have green and red mixed, and then you're going to compete to catch more light. Yeah, so this is just a small little funny demo of that we can now measure our environment with our smartphones. So, are we ready? I think it's not 50-50 at the moment. I need to feed, who's green? Okay, a little bit to be fair. Okay, good. Okay. No. Can we restart this? Green. Have a bit more green. Okay. Now, turn the light off, please. 3, 2, 0. So science can be so much fun. Oh, team B won. Oh, no more. All right, so that's it. Thank you. No more PowerPoint presentations. You keep it.
Thanks.
And Evangelos is going to give a talk about technical details tomorrow around 12 o'clock, so don't miss it. Yeah,
Ready for some questions now? So please raise your hand. People will come around with a microphone, and then you can stand up and ask a question. Your questions?
Sorry, but I'm not really sure what was the point of the experiment. Could you explain it a little bit?
This was about demonstrating that we can really use our smartphones as a measurement device now. And in fact, there are a number of features here. Feature one is we're not interested in what an individual person is doing. We're not interested in your private activity. We're aggregating data, and we're using sensors in a way that's not invading your privacy. For example, the microphone is not being used as a microphone, so we cannot hear what you're saying, but it's used as a noise sensor, and only if you turn it on, right? And in a similar way, we can use all the different sensors. So for example, the idea is that you could create your own applications and games. Could now switch the sensor from light to noise and make a noise competition, or you could change to acceleration and make a smartphone shaking competition, or whatever. I mean, these are funny applications at the moment, but it shows you there's this functionality. Now, it's you to come up with ideas how to use these sensors to measure the world and what you're interested in, because it's an open and participatory platform. It's open source even, and you can put your own applications on top of this platform and do your scientific experiments or create your own games, or whatever comes to mind, or your own company. So that's the idea, and this is just the initial demonstration that, in principle, this can go forward now. as a community action. In fact, I'd like to invite you to establish Nervousnet hubs all over the world. That means small development teams that would join in the development of this infrastructure, which I believe will be important to run our society in a democratic way in future. So this is really important for a number of reasons. And it's going to solve many problems, not just traffic problems and production problems, but also societal and economic problems, potentially. So it's a really powerful new approach and gives us experimental possibilities now.
So it's definitely a oh, should I stand up? Okay, I'm right. I don't know where he's looking. This is definitely has awesome possibilities, but can you say a word about incentives? So how do you get people to actually do this? Why is the average person going to install this on their phone and start doing it?
Yeah, so first of all, I think saying people they should use it is not enough. That's why we are thinking also of these gaming opportunities, because most people want to have fun. Yeah, of course, scientists, besides having fun, also want to do other things with it. And so we are going to put incentive systems on top. We could do that together with you, micropayment systems, reputation systems, so you could collect points of different kinds for joining in, for providing data. And so there will be incentives, in fact. And one day, we might even run economic exchange on the basis of this joint system. So, it's not our system, it's all our system. This is how you should think about it.
Other questions?
Yeah. Thank you for the talk. I want to be a bit provocative.
Sure.
For the big problems of the world, you mentioned things like climate change and other things. Is measurement really the problem? The problems seem to be with policy making, right? With climate change, climate science they have some measurement problems, but not really the science. There is some consensus. And the same with if the problem is to save lives in an earthquake, maybe more than the measurement problem, buildings to earthquake code, having earthquake education, like in Japan compared to Nepal, that would save more lives than a cell phone that tells me, yeah, there's an earthquake,
Yeah, just think of the talk that Sandy Pendleton has given, who actually inspired a lot of this. He was part of the Future ICT project and this idea to create a planetary nervous system. And in his previous talk, he has shown that this kind of approach can be used to improve energy use in environmental issues. So measurement is, of course, only one component of this. Awareness is something that we need to work on, and feedback systems, so incentives, as also Sandy has pointed out before, is really important. But you should see that as a detail of how we run systems in future. And I think we cannot just pass on all the responsibility to politicians to fix the system for us, because we see that this approach has limitations, and in particular because the methods that were available in the past haven't been able to reach out to the local places and find good solutions over there. So it will require our engagement in future to improve our neighborhood and our workplaces and our social environment. What has been missing in the past were tools for coordination. And that's why in the past the lower level activities were so difficult to arrange in a way that could really deliver solutions. And this is now changing. We'll have these coordination tools, and that will complement the activities of politicians and of businesses. So we'll fill the gap, and that's the idea.